Hi, my name is Brian Pollack. I'm the LITE Lab Coordinator at the Museum of Natural History and Science at Cincinnati Museum Center. And welcome to our new LITE Lab. We're going to be doing a lot of hands-on science. Today we're going to be working with liquid nitrogen. Nitrogen is found in the atmosphere all the time, but it's in its gaseous state. When we compress it down, we can turn it into a liquid. And that liquid has a boiling point of 77 Kelvin or minus 196 degrees Celsius. That's really cold. Because liquid nitrogen is so cold, it's important that we respect the safety requirements of liquid nitrogen. And first and foremost, almost everything we do in the lab, we have to wear safety goggles. So I'm going to go ahead and put those on. Also, I don't want the liquid nitrogen to get on my clothes, so I'm going to wear a lab apron. And I don't want it splashing onto my face, so I'm going to go ahead and put on a face shield. And then last but not least, anything I touch, like a beaker, is going to get really cold also because of liquid nitrogen. So I'm going to be wearing special gloves to protect me from the cold of the beaker and of the liquid nitrogen. So I got an ordinary racquetball here at room temperature, and I'm just going to cool it down a little bit. So a racquetball bounces because the rubber of the racquetball is elastic, and it will give back some of the energy that it gets. It also has a little bit of air pressure inside it that will also push back. The air pressure is going to be completely gone in this because it's going to be cooled down so far. And the rubber of the ball is actually going to become a lot less elastic. So that's going to cause it to become brittle and hard, and it'll be a little bit more like a golf ball than it will be like a racquetball. So there's the racquetball, and you can see that it's giving off a lot of fog in that. And we're just going to drop it and see if it still bounces. So here you can see the racquetball did not bounce. The elasticity of the rubber is completely gone, and it's now brittle. And that caused it to shatter when it hit the table instead of bouncing like it. Now I've also got a super ball here, a regular old bouncy ball. Bouncy ball bounces because the rubber inside it contracts when it hits the ground, it squeezes together, and then it releases that energy back again, and that's why it bounces up. So if I put that down in here, just like with a racquetball, I'm going to change the properties of that rubber, and it will become less elastic. Here's our ball. It doesn't bounce nearly as much as it used to. So one of the things I'm going to be showing is a superconductor. A superconductor is a material that has no electrical resistance. And usually that's a temperature dependent, always that's a temperature dependent phenomenon. So in this case we're going to be using this ceramic superconductor that will superconduct at the temperatures of liquid nitrogen. So here it is right here. It's a little ceramic disc. Normally when you think of conductors, you would be thinking of metals. And metals conduct well, and ceramics actually are usually very good insulators. But when we change the temperature, just like with a lot of things, strange things happen. In this case, we're going to create a superconductor by changing the temperature. The other thing I have here is a very small magnet. It's a very powerful rare earth magnet, a neodymium magnet. So I'm just going to get some of my liquid nitrogen here, pour it into the dish with the superconductor. So the really cool thing about superconductors is that they will resist changes in magnetic flux. Magnetic flux is when magnetic field lines go through a material. We call that the magnetic flux. when I take my magnet and bring it close, and I let go, it's going to resist a change to magnetic flux. So there you can see that the magnet is actually levitating. And this isn't a magic trick, this is true magnetic levitation.